Alright, so for this last part of Chapter 5, we're going to be talking about parallel and perpendicular lines. Okay? So let's first talk about what they mean. This question says, what does it mean for two lines to be parallel? Draw example of parallel lines below. Alright, parallel lines, what that means are they are lines that never touch. Okay? So if I have two lines that never touch, like two examples would be, if this line went like this, those would never touch. No matter how long they went, they would never touch each other. Okay? And it doesn't matter what direction they go. Those would be parallel, and those would be parallel. So if you can see, like, it doesn't matter what direction they go, but they're both going in the same direction. That's why they would never touch. Okay? So that leads us to our first important thing. Because they're going in the same direction, think about what we've been talking about Chapter 4 and Chapter 5. Lines are all about y equals mx plus b. And so the two most important parts of this, m is the slope, b is the y-intercept. So if they're going in the same direction, then that means the slope is the same, because the slope is showing you which way it's going. So parallel lines have the same slope, but different y-intercepts. Okay, so they cross the y at different places, but the direction is the same because of the slope. Okay, and that's really all it comes down to. Now, perpendicular. What does it mean for two lines to be perpendicular? Okay, well, if two lines are perpendicular, it means they intersect at 90 degrees, which means it makes like a corner. Okay, so it's not just any intersection. Okay, like, see, these are just regular intersecting lines. That is not perpendicular because it doesn't make a 90-degree angle. So this would be an example of This would be an example of a perpendicular line. Here and here, it makes like a corner of a square. It could also go diagonal. Okay, so if it was diagonal, it would kind of be something like that. Makes the corner of a square. Alright, now here's the key point. Now once again, it's about the slope. These slopes are not the same. They're different, but it's a special difference. Perpendicular lines have slopes that are opposite reciprocals. Okay, so parallel lines have same slope, perpendicular opposite reciprocals, and here's what that means. Okay, we'll do a few examples. So let's say I have a slope of 2 over 3. Well, perpendicular, opposite would mean opposite sign. So this is positive, it would be negative. Reciprocal means flip it. So you got to do two changes. Change the sign, flip the fraction. Alright, what about this? What if I did a slope of negative 4/5? What would be the perpendicular slope there? Well, we change from negative to positive, and then you're going to flip it over, and that would be the perpendicular fraction. Alright, what about a whole number? Let's say we had negative 3. Well, I would have to change it from negative to positive, and then maybe let's make it a fraction so I can see it. So when I flip it, it's 1 over 3. See that? And then let's use one more. What if I have positive 1/2? Well, perpendicular slope, change it, positive to negative, flip it, and that would turn to just negative 2. Okay, so that's the main idea. Okay, parallel, same slope, perpendicular, make sure you make two changes, opposite sign, reciprocal. Okay, so here's how we're going to use that information to solve these problems. Okay, so now we're going to write equations of parallel and perpendicular lines. So we've been writing equations all chapter. Now we're going to write equations of parallel and perpendicular. So problem 1 says, write the equation of the line that is parallel to y equals 2x minus 5 and goes through point negative 3, 5. So look at all this information they give us. They want it parallel to this equation, goes through this point. So let's think about what you've been doing all chapter here. Once again, it all comes down to y equals mx plus b. So what two things do I need to write my equation? Well, I need the slope and the y-intercept, the m and the b. And we've seen different types of problems this chapter where they give it to you where you have to find it. Okay? Now, they did not give me the m. They did. I just had to figure out that, actually. So this is the key. If I want a parallel line to this, then remember we said parallel lines have the same slope. Well, what's the slope? 2. So a parallel line will have a slope of 2. So I got my m. Now I need my b. They didn't give me the b, but I can find it because I have my slope and I got this point. So remember what we do here? We take the y equals mx plus b and we just start plugging stuff in. So what's my y value? We'll look at the point. That's the x, that's the y. So the y is 5 equals m. We know the slope is 2 because it's parallel and it's the same. Parentheses for the x, negative 3, plus b. Remember, I don't know the b. I'm finding the b. So now we solve this. So 5 equals 2 times negative 3 is negative 6 plus b. Solving b, get rid of this negative 6 by adding 6. And we get 11 as b. So finally I can write my answer. So I plug this in and I plug this in. So y equals 2x plus 11. So this is the equation parallel to this. Once again, I just need my slope and my intercept. Okay? Number 2. Now we want to write the equation of the line that's perpendicular to that same equation and goes through the same point. So once again, in order to write the equation, I need my slope and my intercept. So let's think about the slope. Right now the slope is 2. Perpendicular is not the same. I have to make 2 changes. So positive 2 becomes a negative. And then remember 2 means 2 over 1, so I flip it. So my new slope is now negative 1/2. But I'm going to proceed the same way. Start off with the formula. Y equals mx plus b. I have my m. I'm going to go find my b. I'm going to start plugging in the point. The y is 5 equals, now the slope is negative 1/2, parentheses negative 3 for the x, plus b. Okay, so now this is 5 equals, let's use my calculator, negative 1/2 negative 1/2, parentheses negative 3, and we get 3 over 2. Alright, so this becomes positive 3 over 2 plus b. I'm solving for b. Now I know it's a fraction, but just like a real number, to get rid of it, I'm going to subtract it. So let's see what our b is. We're going to do 5 minus 3/2 back in our calculator. 5 minus 3 over 2, 7 over 2. So now we got everything we need. We're going to plug in the slope, the m, plug in the b. So the new equation of the line will be y equals m negative 1/2 x plus b. Okay, so that's all you're doing here. Okay, so pause the video. 2 more problems just like the first 2. Okay, give those a try and unpause it and let's check your answers. Alright, so here's the final answer for number 3. And just real quickly, here's my work. So what did I do? Start plugging stuff into the equation. Here's the y, here's the x. My slope is negative 4 because this is negative 4, parallel is the same. Okay? And then that plugs in, that plugs in. The next one, final answer is y equals negative 3x minus 1. And here's why. This is perpendicular. So when I plug in my m, I don't plug the same one in. Opposite sign and flip it. There goes my b. This is now the new slope. There's the new b. Okay? So it's all about same slope, opposite reciprocal slope. Okay? Now let's take a look at these unusual lines. Okay? So these are kind of like the Hoivux lines. Once again, that shortcut's going to help you. So if I graph this, y equals 4. Remember, y is a hoi, horizontal. 1, 2, 3, 4. So that's the line. So what this means is, if it's going to be parallel, it's going to have the same slope. That means a parallel line will still be horizontal to that. It'll still be a hoi. Now if it's going to be perpendicular, it'd go the other way. So perpendicular would be vertical. So we're still thinking about hois and vuxes. So now it says, what is the equation of the line parallel to this line that goes to this point? So see, remember how this one was y equals 4? A hoi will still be a hoi. So it's still y equals, but what will y equal? Look at the point. 7. With the shortcut, we don't have to do any work. Okay? What is the equation of the line perpendicular to this? So remember, this was a hoi line. Perpendicular would go vertical, so it's going to turn from a hoi to a vux. And vux is x equals. And what does x equal? 1. That's it. Now what if we use the opposite line? Now we got a vux line. X equals -2. Vertical at x equals -2. So now let's think. If it's parallel, it'd be the same. So parallel would still be vertical to this because that's vertical. If it's going to be perpendicular to this, it'd go the opposite way, so it'd be horizontal. It's all about what we start with. So what's the equation of the line parallel to this? Well, parallel would be the same, so a vux would still be a vux. It'd still be x equals. And what does x equal as the point? 4. What about this? What is the equation of the line perpendicular to this? So if the line's going vertical, this vux line, opposite would be a hoi. Hoi is y equals. And what does y equal? 5. So that shortcut, once again, makes things easy for you. Okay? So let's come back here. Alright, so let's take a look. What is the equation of a line parallel to this that goes through this point? So, think about this. Y is a hoi. Slope is 0. Parallel is the same slope, so it's still a hoi. So I'm going to keep the same thing. It's still a y equals, but if it's got to go through this, y must equal 6. That's it. 6. What's the equation of the line perpendicular to y equals -5 and goes to this point? So remember, this is a hoi line right now. Perpendicular would go the other way. So instead of hoi, it would turn to a vux, and that means my equation is now x equals. And what does x equal here on the point? 2. Just like that. Next one. What is the equation of the line parallel to x equals 8 that goes to the point 7, -3? So think about what you start with. I have an x equals, that is a vux. Parallel would be the same, so it's still a vux. So my equation is still x equals, parallel doesn't change it, x equals 7. And the last one, what is the equation of the line perpendicular to x equals -4 that goes to the point 9, -2? So this is a vux line. Parallel would go the other way. So instead of vertical, it would be horizontal or hoi. So instead of x equals, now it's going to turn to y equals. And what does y equal on the point? -2. And that's it. So, with the shortcut, you're just using the Hoivux, but the other time you're plugging in the same slope or changing the slope and plugging it in. Okay, so go ahead and try the practice now.